A titration is a classical analytical technique where an unknown quantity of a particular substance is determined by adding it to a standard solution. That's one that we know the concentration of to a high degree of accuracy. We can calculate the concentration of the unknown by referring to a balanced chemical equation for the reaction. Modern analytical laboratories have auto-titrators which largely do the job for us and allow a large throughput of samples. But if you are asked to carry out a titration manually, on the bench, using standard laboratory glassware, then this is the apparatus you'll need. We're going to demonstrate an acid-base titration. Our unknown is a solution of sodium hydroxide and our standard is a 0.1 mole per litre solution of hydrochloric acid. We prepare this by diluting a commercially available standard. The label tells us we need to dilute to 500 millilitres. Notice we wash the bottle out with deionised water and make up to the mark in a volumetric flask, again with deionised water. Now we need to prepare our burette. First, a quick check of the tap to make sure it turns freely. If it doesn't, it'll need to be taken apart, cleaned and possibly greased. We then wash the burette with distilled deionised water. Now we condition the burette using titrant solution, in other words our standard. Notice we're using a funnel to fill the burette. Sometimes you have to jiggle it a little to get the liquid to flow freely so all the surfaces are coated with standard solution. Notice we don't run the solution out completely to prevent air bubble formation in the tip. If bubbles do form, they can be removed by gentle tapping. If you find bubbles are difficult to remove, it means your burette is dirty and needs to be washed with a detergent. After refilling with fresh standard, we run it out until we reach the 0 mark, or whatever point we can see easily. We record this value, remembering to read off the volume from the bottom of the meniscus, which must be at eye level. Next, we pipette a known volume of our unknown solution into a conical flask. We add a couple of drops of indicator, in this case phenolphthalein, which is pink in alkali and colourless in acid. The white card below the flask will help us see the colour change. We'll start by doing a rough titration. The next step is rather like patting your head and rubbing your tummy. Notice the arrangement of the analyst's hands and how he manages to multitask, swirling and adding the standard at the same time. For our rough titration, we add the standard quite quickly, slowing a little as we start to see a colour change, but we don't worry too much about hitting the endpoint exactly. We record our rough value. A good tip is to use a piece of card or filter paper to help you read the meniscus position. So our titer is about 25 millilitres. Now we repeat the titration accurately. Because we know the rough endpoint, we can add our standard fairly quickly until we approach this value. Let's now fast forward to the point when we're about 3 to 4 millilitres away from the endpoint. Now it's time to slow right down and add our standard drop by drop. Closing the tap, touching the droplet to the side of the flask, and washing titrant into the flask with distilled deionised water. Washing ensures any splashes of reagent are transferred to the solution in the flask. This will have no effect on the titration result. The pink colour is fading. We're almost at the end point. Notice how the indicator changes colour in the region around the drop when the titrant hits the solution. It then reverts to colourless as titrant disperses through the solution to react with the analyte. The endpoint for phenolphthalein is when the pink solution just turns colourless. Finally, we read off the new meniscus position. The titer is the difference between the initial and final readings. Generally, we do a rough and 2 accurate titrations, but if you find the difference between titers for your 2 accurate ones are more than about 1 mil apart, a further repetition is recommended.